So I'm just going to look at a couple of examples of approximate data ill condition systems and how the effects of one little change can have a massive effect on everything within our system. So I've got two examples for you to do. I want you to pause the video, have a read of them, come back and then check what you've done against what I'm going to show you in the video. So here you go. Two questions for you where what I want you to do is compare and comment on the systems of equations given below. So each of them has two sets and two systems. First one and then the second one, you'll notice in the second one I've made a slight change, not a massive one, just a tiny one. Let's see how that affects our overall system. So pause the video and have a crack at those. So the first one, I've got my first system here and I've changed it slightly to the second one by adding 5 onto here. So let's focus on this first system to begin with. Put it all in our augmented matrix, and what I'll have is 500, 1 and 497. I'll then also have 1001, 2 and 995. Now normally when we do our elementary row operations we try and eliminate here so that we end up with an upper triangular matrix. However, if I were to take 2 of the first row off, I'd eliminate this number here in this second row so I could read off the x value. It's perfectly acceptable for us to do that. So if I was to do row 2 take away 2 of row 1, I'd eliminate this number here and I'd then be able to read off my solution for x and then use it to get y. So if I did that, that would change my matrix to 500, 1, 497. That wouldn't change at all. My second row would then become 1001, take away 2 lots of 500, so I become 1. 2 take away 2, which is 0. And then 995, take away 2 of the 497s. It's quite nice because that's just 1. So from that, what I can tell you is that in this system, x is equal to 1. And then what I've got is 500 plus y is 497. So y is 497 take away 500. So y is equal to negative 3. So in our original system of equations, x is 1, y is negative 3 gives me the solutions to this. Let's explore what happens when I make that slight change. So my augmented matrix, first row, still the same, 500, 1 and 497. My second row now becomes 1001, 2, exactly the same, but this time it's 1000 rather than 995. So I've made that tiny change of adding 5 onto here. Let's see how that affects our solution. So I'm going to do the exact same thing. Row 2 take away 2 of the row 1s to try and solve it. What that'll end up giving me, top row of 500, got a 1, I've got a 497 there. My bottom row would then become 1001, take away 2 of the 500, so that would still be a 1 there. Second entry would be a 0. My third entry though in this case would be a 6. So I've made a change in my x. I've gone from 1 up to 6. Now that may not be as substantial a change as we've seen in some of the other examples, but it's still a significant change in comparison to 1. Now if I was to take the x equal to 6 and substitute it into this first one, I'd get y equals 497 take away 6,500, so take away 3,000. So this is now making a massive change, because if I were to do that, I'd have y is equal to negative 2,503. So that tiny little change of adding 5 has made a little difference, not a massive one to the x. Yeah, it's gone from 1 to 6. But the considerable difference has been where we've come from y being negative 3 to y being negative 2,503. That's a heck of a change in our system for such a tiny adjustment in the answer. So this here, fairly ill-conditioned system with such a big change. Second system of equations was this. Now again, I'm going to explore it the exact same way I did before. Take the original one and let's explore the solutions to that. So stick it in an augmented matrix and I get 1, 333, 344, 3 and 1,000 and 1030 there. And in this case, what I'm going to do, row 2 take away 3 row 1s. This time it's easier to eliminate the x. If I were to do that, my top row would stay the same. I'd get 1, 333, 343, then have a 0 entry in the matrix here, then have 1 and 1. So it's quite nice because from that, what I can read off is that y is equal to 1, and if I substitute it back into here, I get x plus 333 is 334, so x is equal to 10. So there's my solution to the first one. Now let's make that minor adjustment and add 4 into the solution for the second equation. Let's see what change that makes. So again, augmented matrix is going to start the exact same. Again, the only difference though, like in the previous example, is I'm going to put that changed element in of 1034 in this case, rather than the original element. Now I'm still going to do the exact same row operation. I'm still going to do row 2, take away 3 row 1s, just to get rid of this value here. What that will then give me is 1, 333, 343 there. And then my second row in this matrix will become 0, 1, and 5. So from that, I can read that y is equal to 5. Now again, it's a change from y is equal to 1. Yeah, it's a bit of a leap. It's not as big as we've seen in some examples. A big thing though I want to look at is what difference has this now made to the value for x. What has this now done for it? If I were to go through my steps and I were to substitute y is equal to 5 into here and solve it through and get myself a solution to this equation here, what I'd find is that the value for x has now become negative 1,322. So a tiny wee adjustment of adding 4 onto that second equation has changed my values from y is 1 and x is 10 to y is equal to 5 and x is equal to negative 1,322. So it's made a massive difference again. Alright, that tiny wee change has made a massive difference in my solutions. This is what we have to be careful for and look out for within ill-conditioned systems when we make that tiny adjustment. If we make a tiny adjustment to one part and it makes a massive difference to the overall solution to our system, it's not exactly the best use of our time. We have to come up with a different technique and we have to look at what we can do with our system itself.